my tardiness, but it was due to actually bank meeting. I'm buying a flat, and there is a number of things to actually take care when you are buying a flat, and thus, sorry. So, my big disclaimer up front, I'm rather a dev person than a DBA person. I'm not a DBA admin, not the DBA as an architect. I'm actually dealt with a couple of databases, and thus, to be honest, that's the most fanboyish presentation I've ever given, or will give. So we'll start with a bit of DB wars, my chosen features, architectural internals, query path optimization, and multi-threading in this all. So Call for History began in 1977 with governmental grant. Mr. Stonebreaker and Mr. Wong actually started doing Ingress, which was interactive graphic retrieval system. This later actually became the base for Postgres, not as in code base, they never shared code base, they shared concepts. Now Postgres was something that University of Berkeley actually developed. So this was kind of a faculty and student project. Nevertheless, it was actually good enough that people used it. They used it quite often. And it gave rise to a number of forks. So Sybase actually came from Ingress. Informix came from Ingress. The first commercial distribution of Postgres was called Illustra, and later it actually influenced Informix. Now, Informix and Sybase, for quite some time, they actually kicked Oracle's ass in terms of market valuability. So people valued them more than they valued Oracle. Now, what's interesting is that SQL Server, the Microsoft one, it actually started when Microsoft approached Sybase and they said, okay, we will give you money, you give us license for actually having Sybase branded as Microsoft SQL Server. That's how MS SQL started. So Postgres is interesting because it actually influenced a number of technologies which are quite common on today's market. Oh, and this is the commercial PostgreSQL today. As you can see, we have Ingress, Postgres, and PostgreSQL. These are three kind of ages in Postgres development. So there is a number of forks, among which I would like to point you to here, Yahoo Everest, which is this and that for some time powered, and I think this even still powers the largest database cluster in the world, which belonged to Yahoo. And still belongs to Yahoo. When it comes to Postgres, there is a number of forks which you may actually look at some point. For example, StormDB, I think some people know it. And people for Windows perhaps know these. Beside versions and forks and flavors, it's good to actually start that Postgres is actually a really nicely supported database. So with each single version, as you can see, 6, 7, 8, or whatever, you're going for a few years because Postgres release cycle is roughly yearly. So you're having a yearly release cycle with pretty much every year getting something new, and you're getting quite some support. Now currently we have 9.6 version, so this slide, which I used at a presentation about Postgres like a couple months ago, is now outdated. So my chosen features, okay? The ones that I actually found really nice. So error reporting logging, which I believe, which I like Postgres for. Then the capability of running your program as in your scripting language on a PostgreSQL server, okay? So within the database, you may run Python, you may run Perl, you may run Ruby and whatnot, which is fairly cool. Handling of XML and JSON, and also handling of pretty much the features which allow Postgres to be used as a NoSQL database, because you can use it that way despite it being object relational database, which is, again, fairly cool. Foreign data wrappers, which is like wave goodbye to your ETL. Then windowing functions, which is quite a powerful SQL concept. CTES, CTES and recursive queries, and power of indexes. So these are my choices for Postgres. So let's go. So thank you to this guy because he is the one who gave me the example idea. So let's say that we create a table. In this table, we want to insert data. So we're inserting data. Now we want to actually get this data, and surprise, MySQL ate my cake. Okay, MySQL ate my cake because As you can see here, the varchar is 3, and I'm inserting something which is longer than 3 characters. Yeah, the behavior is kind of as you could expect it. You can say the cake is a lie, but to be honest, you can also do something else about it, like create the table, do the insert, and get the error. Yeah, because, for instance, if we consider passwords or other more pressing strings than like cake, then we have a problem. So, to be honest, I don't consider this like perfect solution, okay? Because let's say that we have a table where I have first name, second name or middle name, and last name, and say, I don't know, a company name. So couple of strings, yeah? So couple of varchars, and perhaps I set them all to be of length 20. Now, with this message, I know that some of my values are exceeding the limit. Which ones exactly, that I do not know. So this still can be made better, but nevertheless, when it comes to actually inserting wrong values, I often use the Python versus Perl comparison. You see, Python is rather strict, Perl not so much. Perl is much more forgiving. So this is similar when it comes to Postgres. Postgres is more like Python than it is like Perl. So logging, there are a couple of gotchas I would like to walk you through. First of all, default logging is to standard error. Then you have the, if you want to set some values, sometimes you may actually do that from within the client. But quite a lot of times you will not be able to, because some of the values are built into Postgres that much that you can actually set them only when you start Postgres. That is it. So where can you find your logs and how to log your queries? So let's start, where is it? Default directory for the Postgres 9 is data/pglog. For 8th, it was actually per server. If you have launchers, my friend on Mac told me that point, if you have launchers or installed Postgres using Homebrew and are launching it through plist, then your location may be different. If you're actually joining a project and they change the log location for whatever reason, your location will be different. So how to find it? Well, you ask. You may ask your database where you have your logs. So, oh, can you see this? Oh, on the screen there, it's barely seen. So, good for me to know. Now then, option 1 is to ask your Postgres for pretty much any settings in category reporting, logging, where to log. The other option is to do show log destination, which will tell you what is your log destination and a couple of other things. Because if you type show log, you will see what else can you do. So tab completion. Tab completion, actually, some of those things are interesting, like, for example, logging collector. If you wish to log to files, please turn it on, set it to on. If you wish to see your errors, set the minimum error statement, and rotation options you have here. Now then, so to turn on logging, first of all, logging collector on. This is very crucial. People often forget that. Second, you will want to actually use file name. A good thing in file name is that you can actually specify few tidbits which will make this file name, for example, very good when rotating, like date, time zone, and whatever. Log destination is another interesting concept. So Postgres has built-in capabilities for integrating with syslog. So you can send Postgres event to syslog so that actually your Postgres server will not log, syslog will. In some cases you want that. For example, if your syslog is already under, for example, there is, I don't know, Logstash, which actually takes your syslog and pumps it to Elasticsearch. Then you will probably want the syslog to also be the log destination for your Postgres server. Yeah. In other cases, not necessarily. If you would like your logs to be actually slurped back to the Postgres, what you can do, specify that this is a CSV log, then whatever you specified in the path in the file name, you will actually it will end in .csv, and then you can actually slurp it back and have a database. In the documentation for logging, there is even this the schema for such a table, like what will it need. And yeah, pretty much CSV log causes the log to be comma appended. Now then, log statement is interesting, none, DDL, mod, and all. So usually you want to go for all. Now sometimes people are surprised, like I'm having all here, I'm turned this on, and I actually have a good file name, and when I look at the log, I can't see some of the errors that my queries are having. And that is because, but if your queries are having errors on the syntax level, then they will not appear here unless you add this. Okay? If you add the minimum error statement to be error, then queries which have malformed syntax, for example, created with, I don't know, some JDBC driver or whatever, they will be seen in your logs. Now, final thing, which I like very much about Postgres logging is logline prefix. So with this prefix, you're actually able to say time session ID user or database name, for instance, or process ID or timestamp in number of formats. You may tag it. You may actually also say, if session process is looking at this log, please ignore this output, which is sometimes nice to have. So logging is quite powerful, but that's not all. So other chosen features would be something that help me with stored procedure dilemma. So occasionally, your database application and your program, which actually uses your database application, they need to actually use more powerful SQL features. And you're actually thinking, well, I can do this with stored procedures, but I'm a programmer. I don't want to have my code in stored procedures. I don't want to have my logic in stored procedures. Stored procedures are on the database, not in my code. So you have two dilemmas here. Now, interesting thing is that you can have code in your favorite language. There is like over a dozen of options, and this truly helps with pretty much any scripting you are to do. Now, how this happens? This happens that this happens that you're actually writing a function like that. So this is Perl code. Only this and that is something that you need. You're installing Postgres, you're installing extensions to Postgres, you're saying Postgres, I will be using Perl to actually write functions that will be executed on my database server, or Python or Ruby or whatever. Then, if the extension is done, you're creating a function, letting it know that the language is actually PL Perl. And furthermore, ever since this is compiled and pushed to the server, you're allowed to use this function in your queries. So whenever you're actually querying your database, you can have this function and pretty much any other function that you ever wanted. Be it in select, be it in wherever you want. So built-in is support for Perl, Python, and PGSQL. I think TCL also, but I'm not sure since which version. So PGSQL, Perl, Python, and TCL, I think in that order. So built-in support means that if you actually get Postgres core, you have those. Now then, support for XML and support for JSON. So this is actually something which causes Postgres to be fairly cool choice for a database which is, for example, used in microservices. Okay, so if you have microservices, at some point you will probably want a smaller database. Now, Postgres has a couple of features which can help you here. Now, if you want larger database because of some enterprise system, you will have XML as a data type with number of functions which you can use, with good escapes, and so on. If you want, for example, use Redis or any other key value store, also there is a data type called HSTORE, which is pretty much that. And finally, you have JSON if you ever wanted to actually use Mongo. So you're given options to parse and retrieve XML functions, your XML documents. You have functions which allow you actually to even take strings and return it as an XML comment or an XML element. You have also options to throw in JSONs and have it checked syntactically that it's really a valid JSON and so on. Good to remember that Postgres allows you to set one encoding per database. If you don't set it to UTF-8, and you want to use those features, you will weep. Now then, over here you see a data HSTORE, okay, used as a type. Now here you see how I can insert with this type, and this is truly just name, just key and value, key and value, key and value. Now then, also notice here, I don't need to specify every single attribute here, okay? So schemaless, yeah, be my guest. Now then, with select like this and select like that, I'm able to actually use my HSTORE and access it if I choose to do it through queries. So this is HSTORE, XML and JSON data type. So it's as easy as this. So I can have XML file which is input like that and JSON file which is input like that. There is one more format which is JSONB, and JSONB is actually for larger documents. So if you're actually, I don't know, taking whole collections out of Mongo, JSONB is better than JSON. JSON is stored as just a plain text, while JSONB has additional things built in. XML functions give you ability to write like that, and this actually gives you an XML document built like this. So you can nest those functions, you can actually use them, you can get tab completion for them, and in the end, if you choose, you may either use ANSI syntax for XML, because actually ANSI SQL standard already codified how XML should be handled, and there is a number of functions that pretty much any database which follows ANSI SQL standard should have. Also, additionally, you're getting Postgres syntax, which is, in my opinion, nicer. And then comes something which is fairly incredible, which is foreign data wrappers. So foreign data wrappers is stop ETLing and start FDWing. What it actually does is something like that. So in ETL, you have those scripts which do extract, transform, load, and push it to your warehouse. Now with wrappers, you have that, which is actually installed as extension to Postgres, and you're getting your data from Redis, Mongo, file system, other relational database. So you are allowed to take changes from this table and populate them to that table. And you're allowed, by querying this table, to read them or write to it and have the change populated. So fairly cool idea. Windowing functions is something, yeah, this is not just Postgres, okay? Oracle also have windowing functions, and pretty much every most powerful database, relational database, will have them. So what it does, in a nutshell, you're taking a row, you're finding related rows, then you're computing things over related rows, and you're returning the row plus the computed results. So usually, this is not possible unless you're writing procedural SQL. Well, with windowing functions, it is possible. Okay, so you're actually doing that in a query, not in a procedure. So you may do some ranking, you may do averaging, you may actually show growth per time, and various other things. There are a couple of links here which will definitely be to your liking. Common table expressions and recursive queries allow you to simplify your larger procedures, okay? So there are times when your ETL code has same code over and over. You can write it as a common table expression, CTE, and just reuse it. Index. Well, Postgres is actually incredible when it comes to indexes. For example, the new data type, JSON and JSONB, they already have index support. So you can actually, on this type, have keys and search within it and compare JSON documents between themselves, as in which is larger, which is greater, which is later, and so on. You may, of course, create your own index if you ever desire, because pretty much what is very nice about indexes in Postgres is that they are all built on the same architecture. So you can take a look at this architecture, and you can either improve those indexes or create your own and just plug it in. So there are they are geo indexes, which are fairly nice when you're working, for example, with polygons or maps. There are spherical indexes, which are truly cool if you're actually doing anything with animation rendering. To be honest, they are not only used then. For example, in image encoding, they also have indexes which allow you to perform better operations. So number of sites are running Postgres because of those capabilities. And if I recall correctly, NASA also chose Postgres because of that. So architecture. In a nutshell, you have a client and a server architecture, which is nothing new. It's like database since 1980s. And what you have is your client application usually connects through some client library that usually is libpq, and there are first talking to postmaster process. Postmaster process spawns a server process and stops talking with you, okay? Any subsequent calls are going to this Postgres backend process. So as you can see, there is a number of processes here, and what is fairly nice is that you get them, okay? They're not just called postmaster or not just called Postgres. They have actually quite descriptive names. For example, write ahead log process, or replicator process, or checkpoint process, or your name of the database and your name of the user. And you can see when this is your connection actually between your database and your client application. So when you take a look at those processes, this model of actually having separate process for connection, while heavy, it's actually fairly good because of two issues. One, pretty much any decent tool will support processes, system tool. B, MVCC, which is snapshotting of your connections. So with multi-threaded environment and multi-threaded connections, you don't risk having to actually having something from here leak to here, okay? That will not happen. A bit more data. So when you make the connection and you start talking with Postgres server process, what actually happens is that your instance looks kind of like that. So all these are processes, okay? They are called utility processes, and what you're having is write ahead log writer, system logger, the sender and receiver, which is very crucial when you start to do replication, because write ahead logs are used for streaming replication in Postgres. Auto vacuum, which is very helpful for multi-threading, and it actually takes care of multi-threaded synchronization between various connections if you need them, and you need them. And what you have is you're using system memory as in shared memory and per backend memory. This may be somewhat clearer if we go, here. So you have process space, maintenance utility, and postmaster, okay? These processes are per connection. These processes are pretty much for making your Postgres operational. Then you have global memory, shared buffers and val buffers, and the memory per process, which is very good for, and this actually is, for instance, where temporary tables are being held. Data storage is shared between data files, transaction logs, archived logs, and global files. So one more thing here. If you use kill -9 on connections, be aware that Postgres will actually reset every single connection. Okay? So every single process will be actually reset, and you will lose connections on them. So if you want to kill just one, perhaps kill -15 instead of kill -9. Okay. Now then, a bit about directory layout. Pretty much in subdirectories for the data directory, you will find most of what you need, okay? So you will find the subdirectories, you will find the transaction logs, you will find them, transaction logs are actually shared between things for write-ahead logs and things for whether transaction committed, that is commit status. Two-phase commits also will be here, and the stats will be here. Log files will also be present in the data file directory. Log files are only present when your Postgres is actually running. Configuration, this is your main config file, and for starters, I would suggest that you change that. So, in detail covering this would be that you're getting always the shared memory, and the shared memory is governed by postmaster. This is how postmaster and the Postgres processes are communicating, okay, through this shared memory. However, each backend will get their own memory space. Query path. Query path, in a nutshell, starts with a query, ends with a result. First transformation is you take the query text, you're performing several checks through the parser, and you're outputting query tree. Once query tree is completed, then planner takes it, tries to actually rearrange it, seeks the best possible execution, and then it gives out the plan tree. The plan tree is taken by the executor, and the executor then takes a look at every single node and iteratively, actually recursively calling itself on each and every node, it tries to do what the planner decided would be best. The executor also builds this, and this is what you get. Okay? So, what does parser do? If you, for example, mistype, I don't know, select from instead of select from, okay? Then this is what parser is supposed to check. If any catalog lookups, like for example, is this the name of a table? Is this an alias? Do I need to actually change the star into all fields of given table? All those things are again done by the parser. And finally, the tokenization of your query so that the query tree is possible is also done by the parser, which may look kind of like that. You have grammar rules specified, and you have your query tree, okay? And things are supposed to happen in certain order. And again, parser is the guy who watches for whether this order is kept or not. Planner. Planner is where planner tree is built. Planner actually allows you to, planner actually decides what's best. So, inner join or outer join, that's the planner. Join should be merged, should be hashed, or should be, I don't know, nested. Yeah, planner. Which kind of, what is the join order? That's again the planner. If you have aggregation functions, then what to do with them, whether this should be plain aggregation or hashed aggregation or sorted, again, that's the planner. Planner has pretty much the solution for every single query execution. Okay, so what it does, it actually takes a look at the rules, it actually tries to find out how much will it cost you, and then it tries out to come with the best solution. Now, obviously, sometimes there is way too many ways to skin a cat. So then, what Planner is doing, it stops actually trying to find out every single one of them, and instead, if it's using heuristics. So, in a nutshell, checks SQL syntax, builds the query tree, finds a good execution plan, builds the plan tree, finally executes the plan, builds the result. That's how the query goes. So often you will be using explain. So here a very simple explain gives you something like that. So a few words about what you have here. This is cost, initial cost and the final cost. Now please remember that we're talking trees here, okay? So every single item like this is a cost per node. So here we have only one node, so this is the total cost. If you actually think why we have these values here, they are actually the cost of fetching pages, okay, on the disk. So total cost, which is the second cost, is in page fetches. This may change because, for example, you may decide that Postgres per table space will have a different cost to fetch data because your data, your table space is located on different partitions, for instance. Okay? Usually, the cost of fetching a page is considered to be 1, so constant, so to say. Now, rows are estimated. Still, if you have 10,000 rows like this table here does, this doesn't mean that you will have to go through all of them, okay? In some cases, you will have limits or other features which will actually cause you to stop pathway, okay? Estimated average width is, again, if you're outputting something. On occasion, the node will have width being 0. Why? Because it only consults index, and it seeks where in the index are the rows that interest us. So the cost is like this, because times disk pages read times the cost for the page read, then rows scanned plus the cost for the CPU. Default, this is 0.01, this is 1. These are default values. You may change them. They may change on some occasions. But to be honest, I've never worked with Postgres where those values were changed. Not that I'm super experienced. Explain has also explain analyze. So the difference is explain analyze actually runs the query. Okay? So if your DBA is shouting that nobody touches my DB because it's about to die, and you're thinking, okay, I'll just do explain, and you're doing explain analyze, he may come and kill you because you're actually running the query. So explain analyze does the explain, runs the query, and thus collects additional information. For instance, the actual times of execution, whether how many rows were removed by your filter from the total table, what sort method was used when you actually wanted the output to be sorted, how many disk space or memory space were actually used, and so on. So first of all, the actual time, this is here. Don't look for much correlation between this here and this here, okay? The cost is in page fetches. The actual time is milliseconds. These are different numbers, different units. Now then, loops. This is fairly important, okay? Because the actual time must be multiplied, okay? So over here we have a very good example. We have an index scan which for a node lasted only 0.022 milliseconds, which is fairly good, but to be honest, multiply this by 10 because we actually repeated this 10 times. Another thing is this. So when you're looking at explain analyze, the number of rows we predicted we will touch and the number of rows we actually touched, this is something that should stay pretty much the same. They will not always be spot on the same, but they should be very close. Multi-threading. How much time do we have?
1 hour.
Well, then we can continue. So multi-threading in Postgres is actually done on processes. Okay. So first of all, when you're setting up the connection, there is every single process per connection. Okay. So as many processes as you have connections. Now, this allows you to actually have everything totally separated. Now, the other thing which helps is this guy. This is auto vacuum, so automatic cleaner. What really happens is that you're always being served a snapshot of your database, okay? You're not being saved your entire database as it is because each and every single process is getting a snapshot. So you're always operating on a snapshot, and the snapshot always belongs only to your process. Now with that, we're actually took care of dirty read, okay? Dirty read is something that will never happen in Postgres. It's just impossible, okay? So that is why also the serialization levels in Postgres, there are only 3 instead of 4. So interesting thing is that auto vacuum is actually what synchronizes all the things. So when you're doing writes, and when the other process is doing writes, then you're actually being ordered, okay? And there is a mark, and whenever the process is about to do update, it checks whether it passed the mark or not. If it passed the mark, it will actually try to fetch the data. If it did not pass the mark, then it can actually work safely. So this is a very, very simplified multi-threading. This pattern is called MVCC. And we can actually start wrapping up. So in my opinion, again, Postgres is fairly nicely battle tested, okay? It's a stable database. It's used by a number of high-profile people. There is Skype, there is NASA, the International Space Station uses Postgres. There is Instagram and Yahoo with this largest database cluster. It's actually fairly nice and easy to extend. It comes in many flavors. It actually was able to mature since like 1987. You have also very nice support for pretty much every single version that you choose. It follows ANSI standard fairly closely. I think since version 7, they fairly often claimed that they are quite compliant with ANSI standards, more than other databases. You have a number of great features. You can actually, MVCC is built in and you have it by default. You have windowing functions, which is fairly advanced SQL concept. Your error reporting and logging gives you very large number of options. You can handle XMLs, you can handle JSONs, you can handle actually key maps, so pretty much everything NoSQL you can handle in Postgres. Actually, a friend told me recently that they dropped MongoDB because it sucked and they went for Postgres because still they could do JSONs and the performance was better. But never run any benchmarks there, so can't say. You have quite a number of features for actually having powerful SQL, like for example CTES, foreign data wrappers. You can integrate Postgres with number of other databases, which is very good when you're running anything microservices. And if you want to use code for actually having code and you don't have a lot of powerful SQL people on your team, then perhaps the ability of running Perl or Python or Java in your database, not like outside of it, but really built in, might be cool. So you also have nice internals. There is write-ahead logs. There are stats collectors. You should turn them on by default. There is vacuum. Postgres by default handles 12 different ways to actually authorize and authenticate your users, including pretty much everything which is industry standard. The data types and indexes are really come in many flavors, and the processes are really well thought out. You will be able to see which process is doing what fairly easy with pretty much any operating system tool. There is one thing that a number of people will say is a drawback. Postgres people are adamant in saying that our query optimizer is better than humans. So we do not allow hinting. Okay, hinting is actually overriding query optimizer and saying you are to choose this, you are to do that. And Postgres people who come from a number of database backgrounds, they all share actually one common view about that, that very often the hint is left in the code when it actually stops being helpful and instead starts being harmful. So with that in mind, they disallowed hinting. Still, I know a number of DBAs who disagree with that decision. Disadvantages. Besides hinting, it's more like Python than like PHP, and thus a number of times you will be forced to actually learn some of it because it will not work as you want it to work. Okay, so less hacky approaches. There is some learning curve, okay? Let's take a look, for example, at data types. So you want to use a data type and you have like over 30 of them. Yeah, so this warrants some reading. This warrants some time to be spent on this. I often heard voices, I wasn't able to test that myself, that replication in Postgres is very hard to do. Some people say that replication is not as hard, but the performance of the replication is what worries them. Yeah? So if that is important for you, make some tests before you make any decisions. The fact that I can't think of more disadvantages doesn't mean that none are present. So yeah, I'm open for questions and thank you for listening. Okay, I think there are no questions. So still, I'm available for several minutes more, and then I'm again hitting the bank. So thank you very much.